myself Rakhi Kumari, Assistant Professor in the Department of Electronics and Communication Engineering, ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of Microwave and Radar Engineering, we will read Microwave Propagation in Ferrites. So, when we talk about the microwave propagation in ferrites, first of all we have to know what is meant by the ferrite devices. Ferrite is a special type of material or the devices which is made upon using the ferrite material is called as the ferrite devices. Ferrite devices plays a very important role in microwave passive component. Already we have known that passive components are those components which are used in the microwave devices which are not used for the generation of microwave signal. They are just used for passing the signals and giving the signals from one place to another or blocking somewhere anything else like purpose. So, first of all ferrite devices. The ferrites are basically non-metallic material with resistivity nearly 10 to the power 14 times greater than the metals, and the dielectric constant which is given by this epsilon is between 10 to 15 and a relative permeability is order of 1000. They have a magnetic property similar to the ferrous material. They are oxide based component having general composition of the form MEO Fe2O3. Ferrites have atom with larger number of spinning electrons resulting in strong magnetic properties. So, ferrites are those which have a larger number of spinning electrons resulting in a strong magnetic properties, and this magnetic properties are due to the magnetic dipole moment which are associated with the electron spin. So, what are the basic properties of the ferrites? Ferrites are having the magnetic properties which are due to the magnetic dipole moment which is associated with the spinning electron, and because of this properties ferrites find number of application because of this property. Somewhere it is used for the reduce reflected waves, somewhere it is used for modulation, somewhere it is used for the switching purpose. So, as per due to this property it has got a number of application. So, ferrite components are in microwave has find a number of application in the form of isolator, circulator, gyrator, etc. But in today's class, in as per the syllabus prescribed to you, we will go through isolator and circulator. So, before proceeding towards, first of all we should know that what is Faraday rotation in ferrite. So, what is the Faraday rotation in ferrites? When an electromagnetic wave passes through the ferrites, plane of polarization continues to rotate at an angle theta in one particular direction, either clockwise or anti-clockwise. This plane of polarization changes in the same direction whatever may the direction of propagation of wave. So, what is the Faraday rotation? That is, whenever electromagnetic waves are passed through the ferrite material, plane of polarization which is either clockwise or anti-clockwise remains the same whatever be the direction of propagation of wave. So, whatever be the direction of propagation of wave, the polarization of ferrite material does not change. So, this is the basic thing we should remember about the Faraday rotation in the ferrites. Now comes the one important components which is based upon the Faraday rotation is the isolator. So, isolator is the non-reciprocal transmission device. So, sir, for your recap purpose, already we have gone through in the passive components, we have a two type of device, reciprocal devices and the non-reciprocal devices. So, what is the basic meaning of reciprocal and the non-reciprocal? So, reciprocal devices are those devices whose S parameter Sij should be equal to Sji. This is the reciprocal devices, and when this condition does not satisfy, then the device is turned into a non-reciprocal. And why it is used? It is used to isolate one component from reflection of the other component in the transmission line. So, this is the basic function of an isolator in a microwave. So, what is the importance of the isolator? So, when we look at this diagram, let us see, this is a microwave source which are used for generation of the microwave signal, and it is sending the signal to the load where it is required for any specific function. And already we know that 100% reflected transmitted wave is not absorbed by the load, because for this purpose characteristic impedance should be equal. But in the ideal case it is possible, in the general case it is not possible. So, when the wave is transmitted from the source to the load and it is not perfectly matched, then in that case, in the practical condition we can say the wave, some wave get reflected by, and the reflected wave will definitely affect the source which we have. So, when this happens when there is no isolator inserted between the microwave source and the load, and this is the first case when no isolator is inserted between a microwave source and the load. But what will happen when we talk about the second case, when the isolator is inserted between a microwave source and a load? So, what happen? Isolator is that type of device which allows the propagation of the wave in one direction and attenuate in other direction. This is the basic property of an isolator and the basic function of an isolator. We should always remember this, it allows the signal, microwave signal, to propagate in one direction and attenuate or stops in other direction. So, when the signal goes from microwave source to the load, isolator allows. That means S parameter in this case should be active. That means it is able to transmit from 1 to 2. But in the reverse case, isolator blocks the signals from flowing. So, by this application, the reflected wave can't able to reach the microwave source, and due to this, what will happen? Our microwave source get safe. So, what is the major advantage of using the isolator in our microwave signal? Our microwave source get saved. No reflected wave reaches it. Otherwise, if there is no isolator, due to the presence, due to the reflected wave, our microwave source might get damaged. Now, construction and working of a isolator. So, what is the construction and working of the isolator? Isolator basically makes use of 45-degree rectangular waveguide and a 45-degree Faraday rotation ferrite rod. This is the major component of the isolator. Apart from this, it also has a resistive card which is placed along the larger dimension of the rectangular waveguide. So, as to what is the function of the resistive card? So, as to absorb any wave whose plane of polarization is similar to the plane of polarization of the resistive card. What does it mean? That if our resistive card is perpendicular and if perpendicularly polarized, and if some wave is coming to it that is perpendicularly polarized, then that will absorb. So, as to absorb any wave whose plane of is similar to the plane of polarization of the resistive card, and this resistive card does not absorb any wave whose plane of polarization is perpendicular to its own. So, if we have incoming wave is also perpendicular and or we can say vertical, and our resistive card is also plays vertically polarized, and that means both of them are parallel to each other. In that case, waves get absorbed by the resistive card. But think about the reverse case. Our resistive card is horizontally polarized, and the wave which is coming is vertically polarized. That means what happened, what we are going to say, that this wave is perpendicular to our resistive card. In that case, the absorption of microwave signal does not occur. So, this is a one diagram as well, we can say this shows the working of an isolator. One, first of all, what we are saying here, wave is going inside through a waveguide and it is what is vertically polarized, and our this is a resistive card and it is also vertically polarized. So, it will go inside, and what is going on here, our ferrite rod. So, what will happen, this will provide a rotation to it, and again first of all clockwise, then anti-clockwise from this way, and when it reaches the, it is already vertically polarized. So, it will allow the signal, this is also a resistive card. And when the reverse happening, when then in that case this is horizontally polarized, our wave get horizontally polarized. So, in that case our signal get attenuated. So, this is the basic working principle of an isolator. The matrix of an isolator is given by this. This is a condition for the ideal when we say that both the are perfectly matched. So, S11 0, S12 0, S21 exist and S22 0. So, reverse, if this is a non-reciprocal device, that is why these are not equal, these are not equal to each other, and signal propagation is possible in one direction and it is get attenuated in the reverse one. Now comes the circulator. Circulator is basically a multiport waveguide junction in which the wave flow in only from the nth port to the n+1 port in one direction. Although there is no reflection in the number of ports, the 4-port microwave circulator is the most common. So, what is going to happen in this case? Signal flows from in one direction, that is from 4 to 1, 1 to 2, 2 to 3 and from 3 to 4. But when we want that the signal flow from 2 to 1, it is not possible. It is not possible to signal to flow from 1 to 4, and it is also not possible to signal to flow from 3 to 2 and from 4 to 3. So, 1 to 2 is possible, 2 to 3 is possible, 3 to 4 and 4 to 1. This is an example of a 4-port circulator. Otherwise, the multiple number of circulator having number of ports exceeding the 4 is also possible. Now, here is an example of a 4-port microwave circulator, which is a combination of a 3 dB directional coupler and a phase shifter. So, what is going to happen? Let us do one example for this. This is a coupler, this is a waveguide, primary guide and secondary guide, this is a 2 waveguide we have. There is a phase shifter here. So, when you look after the phase shifter, when this it is marked here that when the signal goes in this direction from left to right, this phase shifter give a 180 degree phase shift to it, and when the signal goes from right to left, that in that case this phase shifter gives a phase shift of 90 degree. And here also in the secondary waveguide also we have a phase shifter. So, when the signal goes from left to right, it gives a phase shift of 0 degree, and when the signal goes from right to left, it gives a phase shift of 90 degree. So, takes an example, we are inserting the signal from here. There is one signal is inserted in from here. what happened to that signal? There is a chance the signal goes like this way and some of it get leaked like this. So, we have to check both the signal, and as per this principle of circulator, if we are providing the signal in port 1, it will go to the port 2. So, let us see how it is working. So, first of all we will check this signal. So, when this signal goes like this way and here is a phase shifter first, this phase shifter will provide a phase shift of 180 degree to it. So, when it reaches here, it has a the signal has a phase of 180 degree. And let us look at the another signal, which is coupler, which is the help of the coupler which is coming downwards. So, the coupler provides a phase shift of 90 degree to it. So, coupler provided the phase shift of 90 degree. So, 90 degree here, and now the signal is provided with a phase shift of 0 degree. Because this way from left to right, this phase shifter will provide a phase shift of 0 degree. So, it is going, and again to reach here it has to cross this coupler 2, and this coupler 2 is providing a phase shift of 90 degree. So, this is 90 degree plus 0 degree and plus 90 degree. That means this signal again have a phase of 180 degree. That means same phase, the signal is received here. Now, let us take the example of, so as per the circulator, we know that signal should not be received at port 3. We know. So, let us take this example more also. Let us see. Wave is coming from port 1. So, first one this way 180 degree phase shift due to the phase shifter, and the second one 90 degree. So, it will have a 90 degree. Now, the first signal which is reaching here has a phase shift of 90 degree. Now, the second one, this is coming and this will go downwards, and 190 degree plus 180 degree it reaches here, and again 180 degree, 90 plus 180 plus 90, because phase shifter from right to left will give a phase shift of 90 degree. So, what is 180 plus 180? That means this signal which is coming this way has a phase of 360. That means a phase difference of 270 degree. That means out of phase. That is why the signal is not received at port 3 when the signal is transmitted from the port 1. So, you can verify it with the like this. When the signal is transmitted from 2, it will receive at 3 and from not to any other port, and keep this as an exercise and try to solve whether you are getting the result as mentioned or not. Now, 4-port microwave circulator, which is a combination of a magic T and a phase shifter. So, there is one magic T here, and we know that the magic T has a 4-port. For this one, this one, this one and this one, similarly here also, and this is a phase shifter which provide a phase shift when the signal is coming this way, not this way. So, phase shift of 180 degree. So, let us see, this is one signal and we know that this is the H plane and this is the E plane. Similarly, this is the E plane and this is the H plane. So, as per the property of the H plane, when the signal is inserted, and one thing more, this is the port 1 of my circulator, this is the port 2 of circulator, this is the port 3 of circulator and this is the port 4 of circulator. So, when the signal is goes inside from the port 1, it should reach the port 2. So, for that purpose what we have to do, signal is coming from port 1. So, what will happen? This is the H plane, that means it is equal, divided into equal magnitude with the equal phase, that is we consider it as a 0 degree. It will no phase shift anywhere and it will reach here with a 0, and phase shifter does not provide any phase shift from right to left. So, again same phase, that means, or we know the property of a magic T, if the collinear ports have the same magnitude and have the same phase, it will come in outside from the H plane. So, it will come outside from the H plane, which is our port 2. So, when the signal is coming from the port 1, it will come out from the port 2. So, this is a property of a circulator. We can verify with other ports also. Let us see, port 1 you have provided the signal and it is gone 3, and we already know then when the signal is provided into the H plane, it will never go into the third port, which is our E plane. It will never go into the E plane. And here also signal is coming from the port 2 because of the same phase, but it will never, because when it comes from the E plane, when the phase difference are having the difference, phase out of phase. If the signal have the same phase, it will come out of the H plane. That is why we can say the signal when goes inside with the E first port, it will receive only at the second, not at the third and fourth. Now, this is the matrix of a non-reciprocal 4-port circulator. So, this is the, we are considering perfectly matched lossless system, and we know that it is a non-reciprocal, that is why this can't be same. And now, by using the properties of the S matrix as well as the property of a circulator. So, as per the property of a circulator, what does it mean? When signal is transmitted from port 1, it will goes into port 2 only, not into the port 3 and port 4, and reverse condition is also not happen. So, in this case you can like this, when the signal, well, let us see port 1, 2, 3 and 4. So, this will exist because port 2, 1 is possible, but 1 to 4 is not possible. So, this will be 0. Similarly, this is possible 1 to 2, but 2 to 1 is not possible. This is also not possible. So, as per that you can calculate the, derive the matrix of our 4-port circulator. Now, these are the some of the application of circulator. First one is a duplexer. The duplexer, it works as a circulator. There is a 4-port circulator here, and what does it mean? When the signal is transmitted, is go to the antenna and it will not go to any other point, it will go on this direction also only, and when the signal is received, it will go only to the receiving radar, not to any other place. So, this is one of the condition, one of the application of a circulator we can use as a duplexer. It is also used as an isolator, reflection amplifier, radar system, amplifier system, antenna, transmitting or receiving. These are some of the application of a circulator. Now, let us do one numerical based upon the isolator. Let us see. This isolator has an insertion loss of 0.5 dB and an isolation of 30 dB, and determine the scattering matrix. So, insertion loss 0.5 dB. So, we can write insertion loss as minus 20 log S21. So, we can solve it. So, we can have the, this implies that log S21 should be equal to 0.5 upon 20 minus 0.5 upon 20, and S21 then becomes, this is a log with the base 10. So, 10 on the base and with the power of minus 0.5 upon 20. So, this is the normal equation which we can solve with the natural normal rule which are available with us. By solving, we will get this type of this value as the S21. Now, isolation is 30 dB, which is given by this formula, minus 20 log S12. Similarly, we can find the value of S12, which is equal to 10 to the power of minus 1.5. Since we have considering here the perfectly matched condition, S11 is equal to S22 should be equal to 0. And now, we are framing the matrix which is equal to S11, S12, S21 or S22. S11 and S22 should be equal to 0, S12 value 10 to the power minus 1.5 and S21 value this one. So, in this way you can frame the matrix, and similarly now the another numerical where we have to find out the 3-port circulator matrix. So, this will be the matrix, most probable matrix, and we have to find out the value of each. Here it is not mentioned a perfectly matched case. Insertion loss we can calculate in the same way, 0.5 insertion loss is mentioned here, minus 20 log S21. So, we can find out the S21 value which is equal to 10 to the power of minus 0.025, and insertion loss will remains the same for S21, 2 to 3 and then 3 to 1. So, 3 2 and S13 value should remain the same as the S21 value. Now, the isolation. So, isolation 20 minus 20 log S12. S12 value we have calculated this one. So, isolation will remain the same between the 2 3 and the 3 1. This is equal to 0.1, and now the VSWR we have S equal to 2, and this is our reflection coefficient. Reflection coefficient is equal to S minus 1 upon S plus 1. By solving, we get the reflection coefficient as 0.333. So, that means S11, S22 and S33 is our 0.33. So, now we are having all the values, and by putting the values we are getting the complete S parameter of a circulator. So, in this way you can solve the numericals related to the circulator and isolator. Thank you for attending today's lecture.